The Airbus A350 is one of the most advanced commercial aircraft ever built, and its manufacturing process is a remarkable blend of cutting-edge technology, precision engineering, and global collaboration. Designed to redefine long-haul travel, the A350 represents a shift toward lighter materials, greater fuel efficiency, and enhanced passenger comfort, all of which begin taking shape long before the aircraft ever leaves the ground. The journey starts with design and digital modeling, where thousands of engineers use sophisticated computer simulations to test aerodynamics, structural strength, fuel flow, and safety systems. Every curve of the fuselage, every angle of the wing, and every internal system is optimized virtually, reducing errors and ensuring that physical production begins with near-perfect accuracy. Unlike older aircraft dominated by aluminum, the A350 is built primarily from carbon fiber reinforced polymer, a material that is lighter, stronger, and more resistant to fatigue and corrosion. This choice alone transforms the manufacturing process, as large sections of the aircraft are created using advanced composite techniques rather than traditional metal riveting. In massive facilities, layers of carbon fiber sheets are laid into molds with extreme precision by automated machines, then cured in giant autoclaves under high pressure and temperature, bonding them into solid, lightweight structures. These processes create the fuselage barrels, wings, and tail sections that define the A350's sleek appearance. Manufacturing is not confined to a single location. Instead, it is a truly international effort. Major components are produced across Europe and beyond, with wings built in the United Kingdom, fuselage sections assembled in Germany and France, and other critical systems sourced from specialized suppliers around the world. These enormous parts are then transported to the final assembly line in Toulouse, France, using specially designed cargo aircraft and transport ships, highlighting the logistical complexity behind every finished jet. Once the components arrive, the final assembly begins, resembling a carefully choreographed operation rather than a traditional factory line. Huge fuselage sections are aligned with millimeter-level accuracy using laser guidance systems, ensuring a perfect fit before being joined together. The wings, among the most technologically advanced ever produced, are attached to the fuselage, followed by the installation of landing gear capable of supporting hundreds of tons during takeoff and landing. Inside the aircraft, miles of wiring are carefully routed through narrow spaces, forming the nervous system that powers avionics, lighting, entertainment, and flight controls. Hydraulic systems, fuel lines, and environmental control systems are installed with equal care, each tested repeatedly to meet strict safety standards. The cockpit comes together as pilots' controls, displays, and computers are integrated into a highly automated flight deck designed to reduce workload and enhance safety. Meanwhile, the cabin is transformed from an empty shell into a comfortable environment for passengers, with insulation added to reduce noise, followed by floors, walls, overhead bins, galleys, and seating. The A350's larger windows and higher cabin humidity are direct results of its composite structure, and these features are carefully installed to improve the passenger experience on long flights. Throughout the entire manufacturing process, quality control is relentless. Every component is inspected, scanned, and tested, often multiple times, using advanced imaging techniques such as ultrasonic scanning to detect even the smallest imperfections inside composite materials. Digital tracking systems record the history of each part, ensuring traceability and compliance with strict aviation regulations. As the aircraft nears completion, power is gradually applied for the first time, bringing systems to life in a carefully monitored sequence known as power-on. Engineers check avionics, control surfaces, sensors, and software, verifying that thousands of individual elements work together seamlessly. Before the aircraft can be delivered, it must pass an extensive series of ground and flight tests. On the ground, engines are run at various power settings, brakes are tested under heavy loads, and systems are stressed to confirm reliability. Then comes the moment when the A350 takes to the skies for the first time. piloted by experienced test crews who push the aircraft through a wide range of maneuvers, speeds, and altitudes. These test flights validate performance, fuel efficiency, handling, and safety under real-world conditions, with data streamed back to engineers for analysis. Only after every requirement is met does the aircraft receive certification from aviation authorities, allowing it to enter commercial service. Even then, the manufacturing story does not truly end, as Airbus continues to monitor aircraft performance throughout its operational life, feeding data back into future designs and improvements. The production of the Airbus A350 is more than just building an airplane. It is the culmination of decades of aerospace innovation, thousands of skilled workers, and a global supply chain working in perfect synchronization. Each completed aircraft stands as a testament to modern manufacturing capabilities, combining advanced materials, digital technology, and human expertise to create a machine capable of safely carrying hundreds of passengers across continents and oceans.